All right, let's dive in. Today, we're not just going to be looking at code, we're going to be looking at blueprints. We're talking about how to architect a MySQL database that's not just functional, but truly foundational, something that's actually built to last.
Just think about it for a second. Every single app you use, every website you visit, it's a structure. It's a building made of data. So the real question for you is, are you designing this thing with the foresight of an architect? Or are you just kind of throwing things together and hoping that the foundation holds? Believe me, that difference, it's everything.
Okay, so just like any great building, our database needs a rock-solid blueprint. And this is probably the most critical stage. This is where we lay out the digital land and we draw the floor plan for all of our information to live in.
So how do we actually start? Well, first we use Create Database to stake our claim on a plot of digital land. Simple enough. Then, with Create Table, we draw the floor plan. We define the rooms, those are our columns, and we specify exactly what kind of furniture or data can go in each one. Getting this structure right from the beginning is what prevents total chaos down the road.
With the foundation laid, it's time to put up the framework. Now, these aren't just columns and beams. In the database world, we call them keys. They're the absolute structural core that holds everything together and gives our data building its logic, its strength, and all its connections.
Let's start with the cornerstone of the whole thing, the primary key. This is the one, non-negotiable, unique identifier for every single record. Think of it like a serial number on a product or a specific street address. It's a guarantee that no two rows can ever be mistaken for one another. And crucially, it can never, ever be empty. This is where people often get primary keys and unique keys mixed up, but the difference is so critical. A table can only have one primary key. It's the ultimate boss of identity for that table. But you can have several unique keys, like one for an employee's email and maybe another for their national ID number. And here's the other big difference. While a primary key must always have a value, a unique key can allow one and only one row to be empty or null. Okay, time to connect our rooms. A foreign key is basically the hallway in our data building. It links tables together, like our employees table and our departments table. What this does is enforce something called referential integrity, which is a fancy term that just means you can't assign an employee to a department that doesn't actually exist. This one rule is what prevents so-called orphaned data and keeps the whole structure sound. But here's a common architectural problem you're going to run into. What happens when one column just isn't unique enough on its own? For example, say you've got a table of order items. Well, product ID number 5 might show up in hundreds of different orders. So how do we pinpoint one specific item in one specific order?
The answer is a composite key. We literally combine two or more columns to create a brand new, single, unique identifier. So for our order items table, combining the order ID and the product ID creates a combo that is guaranteed to be unique. That specific product in that specific order. See, sometimes the identity isn't in one piece of data, it's in the combination.
All right, our structure is really taking shape now. But every good building has to follow strict codes to make sure it's safe and reliable, right? In our database, these are called constraints. Think of them as the absolute, non-negotiable rules that prevent structural failure. They ensure our data is clean, valid, and trustworthy from the second it gets entered. And these are our most common building codes. Not null just means a field is mandatory, you have to fill it out. Unique is what stops you from having two people sign up with the same email. Check is for enforcing business logic, like making sure an age is over 18. And default is super useful. If a value isn't provided, it just automatically assigns one for you, like setting a new order status to pending. So what happens when we try to delete a department that still has employees in it? We've got choices. On Delete Cascade is the demolition option. You delete the department, and boom, all its employees are deleted too. On Delete Set Null is a bit more subtle. The department gets deleted, but the employee records stick around. Their department ID just gets set to empty. But what if you don't specify either one? Well, MySQL plays it safe with the default, restrict. This thing acts like a safety lock, and it will actually stop you from deleting the department at all until you've moved the employees. Choosing the right rule here is absolutely critical for data integrity. Okay, our building is structurally sound, it follows all the codes, but can people find their way around quickly? This is where we shift our focus from structure to performance. Indexing is the navigation system for our data, and it's what makes sure we can find anything we need instantly. And when it comes to searching, scale is everything. Searching through 10 records? That's instant. But what about 10 million? Finding one specific entry without an index becomes painfully, brutally slow. It's like trying to find one sentence in a massive library that has no card catalog. The database literally has to scan every single row, one by one.
An index totally solves this problem. It's basically a special lookup table that the database search engine uses to just dramatically speed up data retrieval. It's just like the index in the back of a textbook. It lets you jump directly to the page you need instead of having to flip through the entire book chapter by chapter. It's absolutely essential for performance.
Now listen, not all indexes are the same. A clustered index physically sorts the data rows on the disk. Think of it like the book itself, where the chapters are physically organized in order. And because you can only have one physical order, you can only have one clustered index per table. And it's almost always on the primary key. A non-clustered index, on the other hand, is like a separate card catalog. It has pointers that tell you where to find the data. And you can have a bunch of these, organized by author, subject, whatever you need. And MySQL has some really cool specialized tools for unique data. A full-text index lets you search efficiently inside large blocks of text, like product descriptions. A spatial index is built for geography, making queries like find all coffee shops within 1 mile incredibly fast. It's really all about using the right tool for the job. So, after all this work, how do we do the final inspection? It's easy. You run a simple command, show index from your table name. This gives you a complete audit of your entire navigation system. It shows you every index you've built, so you can make sure your data building isn't just strong, but also incredibly fast to get around in. And that brings us to the final and most crucial question. Look, anyone can throw a database together quickly, but to architect one to actually last, that means having a solid blueprint, strong connections with keys, strict integrity rules, and a fast navigation system with indexes. That is the difference between a temporary shack and a skyscraper. So take a look at your own projects and ask yourself, are they really built to last?